Section 9.5, Applications, Interest and Mixture. The objectives for this section are to use systems of linear equations to solve interest problems, use system of linear equations to solve mixture problems. Example 1, James has two investment accounts. One pays 6% interest and the other pays 10% interest. He has $1,000 more in the 10% account than he has in the 6% account. In 1 year, the interest from the 10% account is $260 more than the interest from the 6% account. How much does he have in each account? Careful reading indicates two types of information. First, he has two accounts. Second, he earns two amounts of interest. Let X equal the amount, principal, invested at 6%, and Y equal the amount, principal, invested at 10%. Then 0.0x is equal to interest earned on first account, and 0.10y equals interest earned on second account. Our two equations are going to be y equals x plus 1,000. Y is larger than x by 1,000. 0.10y minus 0.06x equals 260. Interest from the 10% account is $260 more than interest from the 6% account. Since our first equation is already solved for y, we're going to use substitution and substitute y in for the second equation. So in our equation, 0.10y minus 0.06x equals 260. We're going to replace the y with x plus 1,000, which is going to give us 0.10 times the quantity, x plus 1,000, minus 0.06x equals 260. We're going to multiply everything by 100 so we can have integer coefficients and constants. In other words, we're going to get rid of our decimals. That's going to give us 10 times the quantity x plus 1,000 minus 6x equals 26,000. When we distribute, we will get 10x plus 10,000 minus 6x equals 26,000. We're going to collect like terms on the left and move the 10,000 to the right. That's going to leave us with 4x equals 16,000. Divide both sides by 4, x equals 4,000, which is the amount at 6%. We're going to do back substitution and replace the x in the original equation with the 4,000 and then solve for y. Y equals x plus 1,000, which is equal to 4,000 plus 1,000, which is equal to 5,000. That's the amount at 10%. James has 4,000 invested at 6% and 5,000 invested at 10%. Example 2. Lila has $7,000 to invest. She decides to separate her funds into two accounts. One yields interest at the rate of 2% and the other at 5%. The higher interest account is considered more risky. Otherwise, she would have put the entire $7,000 into that account. If she wants a total annual income from both accounts to be $260, how should she split the money? Again, if we carefully read the problem, we have two types of information. 1, she has two accounts. 2, she earns two amounts of interest. We're going to let x equal the amount principal invested at 2% and y equal the amount principal invested at 5%. Then 0.02x is equal to the interest earned on first account, and 0.05y is equal to the interest earned on the second account. When we set up our two equations, we're going to have x plus y equals 7,000. The total amount invested is $7,000. And 0.02x plus 0.05y equals 260. The total interest from both accounts is $260. Since both equations are in standard form, addition is going to be the method we're going to use to solve this system. We're going to multiply the first equation times -2 and the second equation times 100. When I multiply the first equation times negative 2, I end up with negative 2x minus 2y equals negative 14,000. When I multiply the second equation times 100, I end up with 2x plus 5y equals 26,000. When I add those together, I have 3y equals 12,000. When I divide both sides by 3, y is equal to 4,000, which is the amount at 5%. I'm going to substitute the y equals 4,000 into that first original equation. X plus y equals 7,000, which is going to be x plus 4,000 equals 7,000. Subtracting 4,000 from both sides, x equals 3,000, which is the amount at 2%. She should invest $3,000 at 2% and $4,000 at 5%. Example 3. How many ounces of each of a 10% salt solution and a 15% salt solution must be used to produce 50 ounces of a 12% salt solution? We're going to let x equal the amount of 10% solution and y equal the amount of 15% solution. These problems are best solved by setting up a table. We're going to have one row that's our 10% solution, one row that is our 15% solution, and then one row which is our resulting solution of 12%. One column is going to be the amount of solution. We would multiply that times the next column, which is the percent of salt, and that's going to give us our third column, which is the amount of salt. So in this system, I don't know how much 10% solution I use, so I said that was x. I don't know how much of the 15% solution I use, but the amount there is going to be y. And I do know that my total is going to be 50 ounces for my 12% solution. So our percent of salt is 10%, which is 0.10 as a decimal, 15% for the y solution, which is 0.15, and 12% for the combined solution, which is 0.12. To get the values in the last column, we just multiply. X times 0.10 is 0.10x. Y times 0.15 is 0.15y. And then 50 times 0.12 is 0.12 times 50. The two systems that we're going to write is the amount of solution here, x plus y equals 50. And then the amount of salt over here, 0.10x plus 0.15y equals 0.12 times 50. So you see that down here. The sum of the two amounts must be 50 ounces. That's the x plus y equals 50. And the sum of the amounts of salt from the two solutions equals the total amount of salt in the final solution. That's the 0.10x plus 0.15y equals 0.12 times 50. We're going to multiply the first equation by negative 10 and the second equation by 100. So we're going to use the addition method. When I multiply my first equation times negative 10, I end up with negative 10x minus 10y equals negative 500. When I multiply the second equation times 100, I end up with 10x plus 15y equals 600. When I add those two things together, I have 5y equals 100. When I divide both sides by 5, y equals 20, which is the amount of 15%. When I do back substitution with y equals 20 into the equation x plus y equals 50, I have x plus 20 equals 50. Subtracting 20 from both sides, x equals 30. That's the amount of 10%. You're going to use 30 ounces of the 10% solution and 20 ounces of the 15% solution. Example 4. How many gallons of a 20% acid solution should be mixed with a 30% acid solution to produce 100 gallons of a 23% solution? And here you'll see a little bit of a picture where we have the tub that has a 20% acid solution, the tub that has 30%, and the two together are going to give us 100 gallons of 23% acid solution. We're going to let x equal the amount of 20% solution and y equal the amount of 30% solution. Once again, we'll do a table. One row will be 20% solution, one will be 30% solution, and one will be 23% solution. And then we have an amount of solution column, a percent of acid column, and an amount of acid column. The amount of 20% solution is x. The amount of 30% solution is y. The total amount of solution is 100. Our percent of acid for the first solution is 0.20. For our second solution, it's 0.30. And finally, for the combined solution, it's 0.23. And then we get the amount of acid by multiplying the amount of solution times the percent of acid. So we've got 0.20x for the 20% solution, 0.30y for the 30% solution, and 0.323 times 100 for the 23% solution. Our system of equations is going to be x plus y equals 100, which is the sum of the two amounts, must be 100 gallons, and 0.20x plus 0.30y equals 0.23 times 100, which is the sum of the amounts of acid from the two solutions equals the total amount of acid in the final solution. Once again, we're going to use addition. I'm going to multiply my first equation times negative 20 and my second equation times 100. When I multiply my first equation times negative 20, I have negative 20x minus 20y equals 2,000. When I multiply my second equation times 100, I have 20x plus 30y equals 2,300. When I add those two equations together, I end up with 10y equals 300. When I divide both sides by 10, y equals 30, which is the amount of 30%. Back substitution, once again, gives me y equals 30, and I plug that into x plus y equals 100, which is x plus 30 equals 100. Subtracting 30 from both sides, x equals 70. That's the amount of 20%. So I have 70 gallons of the 20% solution should be added to 30 gallons of the 30% solution. This will produce 100 gallons of a 23% solution.